Hello, everybody, and welcome. I'm YORI NELKEN, one of the 3 general partners on Cognitiv Ventures, which is OurCrowd early-stage investment vehicle, investment fund, in specifically focusing on artificial intelligence companies. I've been doing artificial intelligence since the early 80s. As a young engineer, I joined the Israeli army and did natural language processing. Thank you. And ever since, including the 4 companies I co-founded, everything I've been doing had to do with artificial intelligence. And even so, I've been on the cutting edge of artificial intelligence for so many years. What I've been seeing happening around here over the last couple of years is nothing short of astounding. At last, it feels as if artificial intelligence technologies are poised to change and disrupt all markets, all industries, even the most traditional ones. And with that, I'm really looking forward to seeing the panel today and listening how it unfolds. Let me introduce to you my partner, Avi Reichental, who will be leading this panel. Avi has over 30 years of executive leadership in late-stage global corporations. Prior to joining us at Cognitiv Ventures, and for over 12 years, Avi served as 3D Systems President, CEO, and Director. Under his leadership, 3D Systems emerged as a formidable global 3D printing provider, with revenues growing 6-fold and market valuations growing over 12-fold. Avi is founder and chairman of several early-stage ventures and sits on the board of many others. In 2014, he was named as one of the, listen to that, top 25 makers who are reinventing the American dream by Popular Mechanics magazine. In 2013, Avi was listed as one of Fortune magazine's top 50 business leaders, and in 2012, he received the Financial Times Boldness in Business Award. Avi is an active inventor who holds 25 patents. He is part of Singularity University's core faculty and serves as a trustee of the Cooper Hewitt Smithsonian's Design Museum and is a member of the XPRIZE Innovation Board. Avi, please.
Thank you, Yori, and thank you, everybody, for coming to talk about what I think is the most exciting, frightening, and disruptive force over the next decade, which is artificial intelligence, because I honestly believe that it will touch, shape, define, disrupt, enhance, enrich, displace, and otherwise impact every part of our lives. Quickly to also acknowledge our 3rd partner, Eduardo Choval, who is sitting down here. Raise your hand, Eduardo. Between us, about a century of company building with all of the mistakes that come with it, which we hope to help avoid with our early stage companies. We are sponsoring this chat under Cognitiv Ventures, a new fund in which we expect to deploy about $100 million over the next few years into companies that we believe could become category makers and disruptors using AI. And with that, let me invite to the stage 2 experts in the field. First, let me invite Jeff Herbst. Jeff is Vice President of Business Development at Nvidia, a company that requires no introduction, a maker and shaper in the connected world of computing and actuating, a guy with great experience that has a lot to say about the future. And Michael Radwin, who is from Intuit, another company that has been applying AI into a variety of business practices, and a gentleman that has a great deal of experience in the field. Please come on stage. So I thought that we should start with a little bit of just company background. Jeff, maybe with you. What brings you here to Israel? Why Nvidia is in the center of the AI conversation and transformation?
Sure. Thank you for having me, Avi. Really appreciate the invitation. So a lot of you know Nvidia as a computer graphics and a computer gaming company, and that's where we started. I've been with the company 16 years, and what basically happened at Nvidia was we were the first people to introduce programmability into our graphics processors. And the reason we did that, we weren't thinking about artificial intelligence back then. This was about 2001. What we were thinking is we wanted people to be able to write actual programs to this massively parallel processing unit so they could do effects in games and simulations like fire and water and smoke. And the byproduct of that was, you know, you had these massively parallel processors that were now programmable. So researchers and scientists figured out that this was actually supercomputing capability on a desktop or in a box. So fast forward several years, Nvidia saw this trend, and we built a set of tools and a computing architecture we call CUDA, C-U-D-A. We announced that in about 2008. Once we built CUDA, instead of having to program these graphics processors to do non-graphics applications in graphics programming languages, some of you who may be technical know DirectX or OpenGL. We created a language, and you could program in C all these ways to do these simulations, and people started doing fluid dynamics. They started doing atmospheric simulation. We had a little Israeli company called Rocketic started doing EDA, software acceleration. But what became the killer app for this was deep learning, or artificial intelligence, and convolutional neural nets. So what am I doing here? So this is how NVIDIA went from a computer graphics company to, I believe, the leader in AI. Excuse me. I said this earlier this morning. You know, our market cap this morning when I woke up was $150 billion. People don't realize that's 50% more than
Not
Qualcomm.
too shabby.
Not too shabby. That's 50% more than Qualcomm and about 75% of Intel. And Intel just had a big increase in market value. So what we're doing in Israel is we're trying to build the ecosystem of companies that want to build software applications around graphics processors. And so that's why we invested in Zebra Medical. We're working closely with them. We're involved in another company called Deep Instinct, which is doing AI for malware and intrusion detection. And so we're not trying to compete with these companies or buy these companies necessarily or suck information out of them. We're trying to help them basically use our platform, and NVIDIA's GPU platform is probably powering 95% of the AI training right now. It could be 100% actually. And so we're here in Israel because this is the land of startups. You know, there's incredible research. There's incredible universities. The people are brilliant. So we see a big opportunity to help build the ecosystem here. So I think I've been at least 20, 25 times to Israel. I've lost count. And so we're super excited about helping build the AI ecosystem here. And you're going to see a lot more of us. Some of you may have been in our GPU conference last year. Our CEO was here for the first time, and we established an office here about 1.5 years ago, and that's now growing. So really incredible stuff, and you know, this is continued. Last year was the year of AI. This year is going to be the year of AI. Next year is going to be the year of AI. This is the first technology that we're seeing where there doesn't appear to be a natural end to it.
No, in fact, it's just beginning, and it's been about 4 decades in the making. Like most deceptive technologies, you know, it takes decades to reach critical mass, and all of a sudden people wonder, you know, how did it get to be an overnight success? It's been decades in the making.
Well, I'll tell you why. It's pretty obvious, actually, why it happened. I mean, I studied AI when I was in college many years ago,
yeah.
And the reason is there wasn't enough computing horsepower to basically allow you to do the computation for a convolutional neural network in less than my lifetime. I mean, you'd need to spend your life to just even start to do your life's work. It just wasn't practical. So it was only after you had these massively parallel processors and that called GPUs that were able to run fast enough that you could train in a week, a month, or even a day. And at the same time, the proliferation of large amounts of data on the internet. Those two things coming together caused a big bang.
Yeah, no, it's definitely the convergence of those exponential technologies in infinite cloud computing, ubiquitous connectivity, big data, that's making it possible. I want to bring Michael into the conversation. Michael, your company, Intuit, generates most of its revenue in the United States, and yet you're here. Why are you here? And why Intuit is investing so much in R&D here in Israel?
So thank you. So I came here to Israel to build a AI and machine learning team, and like both of you, I've been doing AI and machine learning also for maybe not quite 30 years, but the technology's been around for a long time, and it is the year or two or the decade of machine learning. And I would add actually a third thing to it's a confluence of GPUs and the ability to actually have all this big data available. The third thing I would add is this open source platform, these technologies like TensorFlow or scikit-learn, these technologies have actually really made it much, much easier. The tools are just so much better than the tools were back in the 90s when I was doing ad targeting at Yahoo and we had to build our own neural networks in C. It was miserable. We got it to work. But so why are we here in Israel? The answer is talent. Intuit is a 35-year-old company that builds financial software. How many of you file taxes in the United States? Raise your hand. Okay. How many of you enjoy filing your taxes in the United States? Okay. So oh yeah, most of you didn't, right? So
enjoy is a stretch.
I think the only people who really enjoy doing tax preparation are accountants, and most of us don't. This is it's something that is required.
I actually do enjoy it. I might be sick. I just enjoy it. Yeah.
So tax preparation is required, but by many of us not desired, and the fact that there are large quantities of data. There are millions of taxpayers in the U.S. and actually millions of hundreds of millions of small businesses across the globe means that there's lots and lots of data, and we can use that data to help transform customers' lives and remove the drudgery, automate these tasks, and actually give them insights or knowledge that can help them to save time, save money, run a better business, or have a better sort of personal outcome. So we started building an AI machine learning team here in Israel because this is where the talent is. This is where we can find people who have experience and have the background, and we also can take advantage of the local ecosystem.
So let's begin to take it to the next level. At the end of the day, both of you are here and excited about a decade of AI because you're looking at monetization opportunities for this technology. You're looking for impact. You're looking to enhance the profitability and sustainability of your businesses and the relevance of your businesses in a period of change. So what are some of the practical applications that you're looking for to be able to enhance and transition your business and be on the side of the disruptors, not the disruptees?
So I would position it a little bit different for Nvidia. I mean, obviously we're using AI in our own business, but we're actually building a platform to enable other people's businesses to use AI. And, you know, like Michael was saying, you know, the tools are out there to make this a very widespread.
So can you name maybe the top 5 applications that you see AI enabling in the next few years?
So I think the top 3 would probably be automotive, healthcare, finance, security. I mean, automotive is probably the biggest near-term practical use case that people can see in their, you know, happening. I mean, all this opportunity in self-driving cars is all powered by AI. And, you know, when we started building kind of a self-driving car technology, we were doing computer vision. And even Mobileye, as a great company, you know, They started as a computer vision company. What people realized pretty quickly was it was going to be impossible to program every possibility using an actual hand-tuned algorithm. I mean, you could have people working in China and India for years and years, and they never find every corner case. But the best way to do it, you know, is basically to, you know, teach the car learns through its own experience. And so AI is all about pattern recognition. So you can much more quickly train a convolutional neural net to recognize patterns and take actions than you can. So that's going to be a big application. You know, obviously, I left out the big first users of this, by the way, were the big hyperscale internet companies, you know, Google's and Facebook's, the people that had lots of images and video or they needed to tag faces and things. I believe, you know, that's kind of a solved problem. Of voice as well. Those are becoming really solved problems. The next wave is really going to be big data analytics, and so we're working with a lot of companies doing that because most of the world trades in data. They don't trade in images, and most data sitting in the world is unused and stored. And so we're working with a host of companies doing that. Healthcare, another one. You know, we heard from Zebra Medical this morning, so they're taking radiological images and they're able to predict or find diseases much better than a human can. Finance, insurance industry, being able to predict behaviors, eventualities. We're working with a host of companies doing that. So I think it started, you know, in these hyperscale internet companies, and it was the Andrew Ng's of the world and the Jan LeCun's of the world. All these companies hired one of those guys. And they were the pioneers of figuring out how to do this, and they all kind of converged at Stanford University for the ImageNet competition, where basically there was a contest every year to see who could recognize images better. Once people figured out you could use convolutional neural nets and you could use GPUs and you didn't have to hand code computer vision, these guys became like, you know, I joke with them when I see them, you know, they were has-beens, you know, their families were probably telling them, go get a life, you know. AI's been around for so long, and all of a sudden these are now the rock stars of the tech industry, and so Google and Facebook paid them all lots of money to go help them, you know, find similar items, you know, serve up ads, but I think it's beyond that right now.
Michael?
Yeah, I'd say it's much beyond that right now. We think that there's at least 3 really interesting applications of AI and machine learning. One is what we would generally call smart products. So how do you help a taxpayer avoid making a mistake or help a small business make better decisions? The second is around security, risk, and fraud, and entirely new products can be built there, such as QuickBooks Capital, which helps small businesses get access to loans that they couldn't have otherwise gotten because it's based on this fine-grained data that normally banks just can't actually see. And the third is around what we call customer success and expert advice. If you look at things like the United States tax code, again, 80,000 pages of text written by the US government, and actually interestingly, it's this legalese or this bureaucratese is actually easier to understand than English because it's sort of English and sort of not English. And so using natural language processing, it's actually an easier problem to be able to decode this text. And so this is actually what we're doing, which is we automated the production of a product like TurboTax, and we're expanding this to other compliance regimes outside of the US tax prep space. Can you consume 80,000 pages of text and actually spit out a functioning software product that actually knows all of the rules and all of the graph and all the edges and all the ways that the inputs get transformed? So these are 3 different ways that you can use AI to make your business run faster or to actually embed it into the products and make the customers' lives better.
You know, as I think about it, as you're talking, that makes total sense. The answer is everything. It's almost everything except maybe things that require kind of very high-level emotional intelligence, super high-level judgment and experience.
Empathy and emotional intelligence, which I have to share with you. Like, you know, once a year I do this Singularity University get-together. And of course, you know, we had Ray Kurzweil there and Peter Diamandis and all the other core faculty members from the early days, my humble self included. And for the first time, there is a lot of talk about AI actually learning how to mimic empathy and emotional intelligence. And of course, we have this very recent example of the transition of DeepMind, you know, the Google acquired company that went from AlphaGo to AlphaGo Zero. And the difference is that in AlphaGo, Go is the ancient Chinese game. In AlphaGo, of course, algorithms learned from other players how to play the game. They looked at thousands of games, and eventually they were able to beat the champions in the game, right, to the tune of 100-0. In AlphaGo Zero, the experiment was, let's train the algorithm to learn the rules of the game and let the algorithm learn from itself, right? And so the big innovation in the experiment was, we're not going to look at data, we're going to teach an algorithm the rules of the game and let it play against itself. It took them about 40 days to get to a point where the algorithm was the most knowledgeable player in the world. When you begin to think about the ramifications of an example like this, where does it take us?
So I think we're a long way from going and learning how to play a game to learning to not just mimic emotion, but actually be able to feel emotion. Where we've seen...
What is a long way? Is it 5 years, 10 years, 15 years? I mean, quantify it. Try to be a futurist
yes.
for 5 minutes.
In our lifetime, certainly is it, but I would put that in the 10 or 15 years, much more than in the 0 to 5 years. The places where we are using machine learning the best right now is what we call the supervised machine learning, where we actually know who are the good guys and the bad guys, which transactions are fraudulent, which transactions are good, who's male, who's female. Even this is hard to know sometimes. These labels are fuzzy, but when you begin to talk about emotion or talk about these deep interactions, you're stepping outside of the supervised machine learning world into this unsupervised world, and we haven't seen the same breakthroughs in unsupervised machine learning the way that the confluence of the three things we were talking about before. Like we need another decade's worth of research to make a
right now people don't even understand this very well. I mean, there's massive amounts of data. And by the way, I tend to use the term deep learning rather than machine learning. Yeah. To me, machine learning means hand coding algorithms. So, you know, we talk about AI, which is kind of the superset of things. Deep learning we refer to as, you know, pattern recognition, convolutional neural nets. But what people don't realize is there's all these massive amounts of data out there. The problem is you got to supervise the training. So there are people all over the world, you know, especially low-cost countries, who are tagging images for us and for other companies, automotive data and stuff like that. So we're still in that mode right now, and there's all this dark data that people don't know how to tag and don't know what to do with. So we're working on unsupervised algorithms, but I think, as Michael says, it's a ways off right now. But the breakthrough could come any day. We just don't know.
Yeah, I think that one of the challenges for us is to, you know, we're trained as humans to think linearly. And some of these technologies are clearly developing exponentially. And one of the perhaps missing elements for us to comprehend is that, you know, when you get to deep learning, the speed and efficiency and computational power that we're talking about exceeds our ability to imagine timelines for breakthroughs.
So the challenge for us in this field of whether it's machine learning or deep learning is, can we get our hands on the data? Is there enough data? Because we've seen that when you have large quantities of data, deep learning actually works really, really well. When you have small or medium-sized data sets, actually deep learning doesn't work very well. And this is like, you know, we spent so much time this past decade talking about big data, but actually most data sets aren't big data. They're medium data or small data. And so maybe this is why I don't focus exclusively on deep learning. I look at the sort of the more classic machine learning approaches as well. We need to be able to digitize the data to be able to get our hands on it. And actually, not all the data sets are available. It's not everything is Wikipedia.
Yeah, and then they're not clean. So, you know, there are companies out there. So we've actually invested in one called Datalog. So their whole paradigm is their data cleansing company. You have to take all this data and you actually have to put it in a form where you can do pattern recognition on it. And a lot of the data is just not there yet. So, no, I agree with you completely. But you're right. I mean, the reason why this is such an amazing time and breakthrough in technology is we don't have to hand code all the algorithms that are going to break, you know, into the future. And so the rate of change of technology, instead of being linear, is all of a sudden going to be like this big hockey stick curve, because and we are at the point where data can do the programming instead of humans doing the programming. So that's why I am extremely bullish on tech right now, and every company in tech has got an AI strategy. If you don't, every company non-tech ought to have an AI strategy. And if you don't have an AI strategy, you may be dead and not even know it.
Well, that's exactly right. Now, with every period of exciting technology disruption, there is always the unimagined positive possibilities and potentially unintended consequences. Surely both of you have given some thought to the unintended consequences of this technology, particularly if it falls in the wrong hands. Talk to me about that a little bit.
So I can start and share that The Economist did this survey of accountants a couple of years ago and asked, how likely do you think that your profession is going to be replaced by machines? Actually, they looked across many industries, and I think accountants were the worst. Something like 92% of accountants fear that they're going to be out of business in the next 10 or 20 years. I don't agree with this. I think we can see that AI and machine learning are tools to make us superhuman, to make humans smarter instead of taking away our jobs. The fact that you can give these tools to accountants and take away some of the really, really simple tasks and then let them be a more intelligent advisor to the small business actually both moves them up the value chain and makes their work more rewarding. So
but let me push back on that a little bit. I mean, we see a race in autonomous driving that clearly suggests that in the next decade we're not going to have taxi drivers or chauffeurs or truck drivers. I mean, you know, there may be a transition period, but what do you say to a taxi driver or an Uber driver? I mean, how are they going to move up the food chain? What do you say to the millions of people that men and women that are truck drivers? I mean, they're surely going to be displaced by this. I'm not even so sure about the accountants. I mean, you know, this idea that we're building a bridge to abundance and that we're going to multiplex ourselves using AI is true, but I think there is a time gap. The disruption is more immediate and imminent than our ability to evolve and create, you know, the superhuman. So I'll give you a chance to respond, Michael.
So I studied computer science, not philosophy.
Not the human condition.
Not the human condition. So if we look at history, if we look at all of the revolutions that we've had, the Industrial Revolution, the Information Revolution, we've always actually just continued to grow the world's economies and the world's prosperity. So I have some naive optimism in the human race that we'll be able to.
I mean, let me give you an example of a new industry that gets created. So, and I agree with you. I mean, people said when we stopped using horses, you know, what were going to happen to the blacksmiths that put the horseshoes on, and everybody found new things to do. But, you know, there's a shortage of healthcare doctors. Especially, we were talking about it this morning. There's a shortage of radiologists, and so, you know, maybe the truck driver, with AI, we're going to be able to diagnose. Doctors are not going to have to be there, especially in remote areas, to diagnose people. The AI is going to be able to diagnose them. That'll open the market for different kind of healthcare workers who can actually, instead of having to have an MD, they can be, you know, a physician's assistant or a nurse in a remote area. So I think a lot of the truck drivers and the cab drivers, at least in the US, which has an aging population, are going to have to get into healthcare. There's plenty of shortage of jobs. It's just, there's going to be demographic shifts of what people are going to do. And AI is going to allow people to do things that they wouldn't have never been able to do before. You know, the AI will say, just stick the needle here and push and do, you know, and they'll be able to do it. And right now, those jobs can't exist.
Yeah, I mean, to make the conversation a little bit more challenging, I mean, I would say that it's very true that in our historical transitions from an agrarian society to an industrial society, and from an industrial society to a connected, you know, cyber society, we managed to transition and improve humanity overall. However, the timelines that we're talking about here are vastly compressed by comparison. You know, these kinds of evolutions used to take decades and centuries. Now we're talking about periods of 3 to 5 to 10 years. And my sense is that we're going to have a disconnect, you know, between the disruption timeline and the recovery timeline. There's no question in my mind that on the other side of this disruption, humanity will benefit, abundance will be created. We will have perhaps the first brain upgrade in a few million years, in the sense that our AIs will enhance our functionality and utility and quality. But in the process, you know, we may have a generation that will be adversely impacted.
Yeah, you're right. And I'll tell you, a bigger problem is people are going to live longer because healthcare is going to get better, and they're going to have more idle time, and it's going to cost more to feed them and clothe them and all that kind of stuff. So I kind of agree with you. You know, we're going to have to go figure out, you know, how all these issues. And that's not, you know, obviously we take that pretty seriously, but we're in the stage right now where we're just providing the tools and the platform and building the ecosystem, and, you know, you're looking 5 or 10 years ahead of that.
I would add that when we introduce new technologies, people have to figure out how to use them and how to adapt to them. And this is one of the learnings I've seen in my career doing software and doing AI and software, is that you have to blend really, really great technology, really great machine learning models with really great design. And we're working hard to develop these algorithms that are going to be building self-driving cars or helping to automate diagnoses of diseases. But if we can't build amazing user experiences, if we can't actually design it in a way that people who are using this technology understand it, that can make use of it in their daily lives, it actually won't work. Many of the experiments that I've done across my career in machine learning have the best, highest precision algorithms with, you know, really great recall, really great precision. But if they fail, if you have a really bad user experience, if you don't sort of explain to the customer why are you making this recommendation, and so this is, you know, we need to invest as much in the tools and the data collection, the data cleaning, the predictive algorithms as we need to in making like real human-computer interaction, actually building game-changing design.
Until AIs do it for us. Right? Speaking of user experience, let's open the discussion and invite some questions from the audience. Yes, sir. Okay.
No, you're absolutely right. You know, there is a shortage, but it's going to take a little bit of while for people to be retrained and for the schools to start teaching. And I mean, like I said earlier, I mean, the guys who are now on the cover of, you know, Time magazine, you know, the fathers of AI, these were kind of has-been, you know, professors at, you know, pretty good universities not that long ago. So I think there's a lag time. But, you know, even at Nvidia, you know, we're retraining a lot of our software programmers and engineers to do AI, and I think it doesn't take that long, and so I think we're on the way to solving this.
Yeah, I would add that we, so our philosophy about why did we build a development center in Israel is because we look for the best, you know, we call them 10x engineers, and we look for the world's best talent wherever we find them. It's not about saving money or about building a development center offshore to reduce the cost. And so it is hard to find these talented data scientists, machine learning engineers. In addition to the universities actually coming up with programs in data science, and actually I think Jeff and I we went to the same university in the US for undergrad. It used to be that biology was the most common undergrad major, and at Brown University now it's computer science. I think the same is true at Stanford as well.
You were a computer science major.
Yeah. And
did my mic go on?
So we know that the universities are catching up, that they are focusing and actually creating programs not just in computer science but in data science in particular. And there's also these amazing boot camp kinds of programs. There's something called the Israel Tech Challenge, which, you know, we've hired a couple people into our company out of this program. Amazing way to take people who have some strong background in statistics or mathematics or just anything, and then you turn them into a data scientist in 8 weeks or 12 weeks, and really like amazing talent coming out of these programs. So both from the traditional universities and from these sort of new forms of education, we will be able to find the talent to be able to build this great future.
By the way, you're right though. It is a little scary because I went back to Brown for my reunion, and I'm sure you spent some time with Andy Van Dam when you were there, like me. He's like my idol. And we started talking about AI. He's like, yeah, this is a couple of years ago. Yeah, we're kind of looking into that. We're going to start teaching our first course on it. I was like, wow, you guys better get moving. You know.
Next question. Yes.
So let me see if I can address. So I think IoT is going to be really important, and one of the big issues with IoT. Oh, do you want to?
What is the role of IoT to advocate and make AI more inclusive for low-tech industries and for younger generations? That in the next 5 years, 45% of jobs are going to disappear.
Well, what I was going to address is the IoT question is really a good one because, you know, a lot of data is going to be created on the edge of the network through IoT. So you're going to have cars driving around, you know, gathering data. You have everybody carrying a cell phone gathering data. So this is actually a big issue. And so all this data that's being created is going to have to be processed, and it probably can't all come back to the server when it's processed. So we're working with companies and with platforms and pieces of software that are dealing with stuff on the edge. And what's interesting is all that data probably can't be stored before it's analyzed. So you have to figure out a way to do the AI before it comes back to the central. So how is this going to, you know, level the playing field or help you? That question I'm not sure how to answer. I think that's kind of a third order to that, but maybe Michael has a better idea.
I mean, I can just add that the reason why these deep learning or machine learning algorithms work is because of a huge quantity of data. And yeah, so IoT, these devices, these sensors are collecting so much more data than when you think about people having to like manually enter information. I think about bookkeeping or accounting. And so for me, what's fascinating about IoT is we think about something we talk about in consumers, this idea of the quantified self. People are wearing these little fitness trackers or things, or they're measuring their blood pressure. They're sort of measuring themselves. We think about this idea of a quantified small business. And so what happens if you have small businesses who have these very, very inexpensive sensors that they can place in their business that are measuring whatever you need to measure. If you're an ice cream shop, you're measuring the temperature in your freezer to make sure that your ice cream isn't melting. If you can link the sensor data, which is this very, very high quantity data with what we call labels, this truth about, well, this turned out to be a really great day for the ice cream shop, or this turned out to be a bad day, and we link it up with the sensor data of the weather outside. You have sort of the complete machine learning, the whole training loop around having this low-level sensor data as well as the actual outcomes, what was success or what was failure. How can we use this for young people and the next generation? My only answer here is that we see that people are the younger the generation is, the more readily they're adopting this technology. They take the smartphones for granted. They were born thinking that you could just swipe on a computer or on a TV screen. So I think they're just going to be much more open to adopting and using the technology, and it's our job to build the software to actually take advantage of it.
Yeah, I mean, if I was coming out of school right now, what I'd be doing is I'd be looking at every kind of legacy industry and go figure out how to disrupt it using AI, because I think there's huge opportunities for young people, creative people who are going to do that, because pretty much every industry is going to be affected by AI, and a lot of people are just too entrenched and they can't figure it out and they don't see it coming. And so, I mean, just look at what Uber did. I mean, this is going to be basically an AI company pretty soon, once the fleet is self-driving and all the data. I mean, it's incredible. I mean, everything is basically going to run on AI. So that's just one example of a legacy industry being disrupted. There's hundreds more to come. That's why you have so many startups here, especially in Israel, and most of them are run by really young people.
So bringing it all back home, if I was asking you to give me advice, I mean, we're embarking on our third fund here that is going to invest only in AI-enabled business models. Cognitiv will deploy about 100 million over the next few years. What would you advise me as an investor? Where should I look? Where should everybody here in the crowd look to harvest the upside of this imminent disruption?
So I would look for people who understand both the technology and also understand how to solve an important customer problem. It's this blend of actually not just taking the technology and trying to hit any problem over the head with it, but actually very, very smart design sense, very, very smart deep customer empathy. This is where I would put my investments.
Yeah, so I see tons of companies. Almost everybody doing deep learning and AI comes through Nvidia. I think there's a lot of problems that have already been solved. Basic perception, image recognition, voice recognition. Stay away from the stuff from 1 or 2 years ago. The stuff that's coming in a big way right now is data. Data analytics using AI hasn't been solved yet. And there's going to be a ton of companies and a ton of good opportunities. And then robotics. This is an area that's basically going to be changed and fully enabled using AI. So those are the two places I'm the most excited about right now.
One last question from the audience.
Well, I think we talked about this at the beginning. I think everyone says this time is different. This time is really different because these algorithms have been around for a while. These concepts have been around for a while. You finally have computing horsepower that's able to actually do it, and you have enough data that's able to do it. What could slow it down? Regulatory concerns, societal concerns, governments. Presidents that don't know how to use a computer. I don't know,
I'd say the biggest risk is in not understanding the customer's privacy and the security of the data. It's not about the technology being able to apply and actually solve the problems, but it's about carelessness or about if we don't actually really understand that the data doesn't belong to us, it actually really belongs to the customer, and we have to keep their best interests at heart and secure their data. Like another Equifax type breach, this is what concerns me more than whether the technology, whether the machine learning will disappoint.
Yeah, I would say it's virtually unstoppable because we do have the perfect convergence of ubiquitous connectivity, high-speed data acquisition, sensing, robotics, and unlimited computing power in the cloud, which we never had before. Those have been significant obstacles to scalability in the past. And we might go through some regulatory periods, we might go through some speed bumps, you know, in terms of adverse societal reactions, but this is unstoppable. It's going to impact everything. And with that, Jeff, Michael, thank you very much. How about a round of applause to our panel?